Welcome back to the Explainer. So today we're going to look at data analysis in a completely different light. Actually, we're going to treat it like detective work. We are unpacking the exact tools that big organizations use to sift through just massive amounts of information to find clues, solve problems, and ultimately predict the future.
And really, this is the ultimate million-dollar mystery, isn't it? Think about it. Every single time you scan a loyalty card, click on a movie, or buy a cup of coffee, data is being recorded. Warehouses are literally overflowing with this stuff. But raw data on its own, it's just noise. So the real challenge, and the central question we're exploring today, is how businesses actually take those literal mountains of stored data and turn them into actionable, profitable decisions. How do they actually make sense of the whole shebang?
Well, here is our investigative roadmap for today. First, OLAP, what just happened? Second, data mining, hidden patterns. Third, the predictive toolkit. Fourth, spotting the unusual. And finally, the ultimate BI showdown.
All right, jumping into section 1, OLAP. What just happened? So before we can even think about predicting the future, we have to understand the past. And our ultimate goal for doing that is business intelligence, or BI. BI is all about turning stored, integrated data into useful information for making decisions. Now, notice the heavy emphasis on the word useful there. Just having data isn't enough. BI is the overarching process of making it actually make sense so managers can do something with it. And to achieve this, organizations rely heavily on two very specific investigative tools. Let's meet the first one. Say hello to our first detective, Online Analytical Processing, or OLAP for short. You can kind of think of OLAP as the classic beat cop. It arrives at the scene and strictly reports the descriptive facts. OLAP provides super fast multidimensional analysis to answer two absolutely fundamental questions. What happened and where did it happen? And when we say multidimensional, we literally mean OLAP lets users examine the exact same data from multiple different angles or dimensions, like looking at it by time, then location, then department or product category. Let's actually look at OLAP in action with a classic drill-down sequence. Picture this. A manager is looking at a really high-level summary. Step 1. They view quarterly sales across an entire region. Let's say they notice a dip, right? So they change dimensions. Step 2, they drill down from that big regional view right into the specific details of a single individual store. And then step 3, they now have the specific location data to actually investigate that poor performance. OLAP works brilliantly with data warehouses because the data is already cleaned up and structured, which is what allows for this rapid, interactive exploration.
So OLAP is incredibly powerful for descriptive reporting, right? It tells us the what and the where. But what if we need to know why it happened? Or, even more importantly, what's going to happen next? Well, answering those questions requires a totally different set of skills.
Which brings us to section 2, data mining, hidden patterns. If OLAP is the beat cop just reporting the obvious facts, data mining is our forensic investigator. Data mining is the process of analyzing large data sets to discover hidden relationships, trends, or unusual behavior that you just wouldn't spot from a simple report. It goes way beyond just summarizing data. Data mining uses serious statistical and machine learning models to extract deep, meaningful knowledge that is quite literally hidden away within the numbers. Moving right along to section 3. The predictive toolkit. To find these hidden relationships, our forensic investigator brings a highly specialized set of tools to categorize information and forecast outcomes. The first tool is classification. Classification assigns records to known, predefined classes or categories. The absolute key word here is known. We already have specific buckets created, right? And the data mining algorithm's job is to look at a brand new piece of data and actively decide which bucket it belongs in based on past patterns. Here is a perfect example of that in the real world. Every single day, your email provider uses classification to predict whether an incoming message belongs in the spam bucket or the not spam bucket. In business, a massively valuable use of classification is predicting whether a customer is likely to stay or likely to leave, which is known as customer turn prediction. Because think about it. If a business knows you're in the likely to leave bucket, they can proactively send you a discount code to keep you around.
Now, contrast that with our next tool, clustering. Clustering groups similar records together without preset labels. So with classification, we gave the algorithm the buckets. But with clustering, we just hand over the massive pile of data and say, hey, go find the natural groupings. The algorithm itself discovers the similarities and creates the clusters totally organically.
And this brilliantly illustrates how modern media works. Just think of your favorite streaming platform. They use clustering to constantly mine user activity. They group viewers by similar behaviors to improve recommendations. If the algorithm clusters you with people who watch a ton of sci-fi documentaries, well, it knows exactly what to suggest to you next. It is a fantastic tool for market segmentation. And this all builds directly into pure prediction through a tool called regression. Now, unlike classification, which predicts a category, regression predicts a continuous numerical value. By analyzing historical data, like say the past month's sales, regression models can actually calculate a highly educated estimate for the future, like predicting exactly what next month's sales revenue will be. This is absolutely essential for organizations that need to forecast demand so they can plan out their stock levels.
Okay, Section 4, Spotting the Unusual.
Now we are moving into the second half of our toolkit, which focuses on tracking specific behaviors. First up is association rule discovery. This technique finds items or events that tend to occur together. A standard summary report might just tell you how many items were sold, totally missing the relationships between those items. Association rules uncover those hidden links.
A classic example of this is market basket analysis in retail. If a supermarket mines its basket data, it might find the customers who buy bread heavily tend to also buy butter. And once you discover that association rule, it directly improves your product placement. You literally just put the butter right next to the bread to maximize convenience and sales.
Taking that a step further, we have sequential patterns, which discover ordered sequences over time. Think about a standard customer journey. Step 1, a customer buys a new phone. Step 2, they buy a protective case. Step 3, they buy some earphones. Understanding this sequence is incredibly powerful because it tells a business exactly when to improve their marketing timing. I mean, why advertise a phone case before the phone is even bought? Sequential patterns help you pitch the right product at the exact right moment.
The final tool in our kit is perhaps the most critical when it comes to safety and security, and that's anomaly detection. While the other tools are looking for common patterns, anomaly detection is actively hunting for the exact opposite. It identifies unusual records or unexpected cases that differ strongly from the norm. Essentially, it's looking for the things that just shouldn't be there.
And the stakes for anomaly detection are incredibly high. For a bank, anomaly detection means analyzing transaction data to instantly identify suspicious behavior and stop credit card fraud dead in its tracks. In healthcare, it could mean flagging an unusual medical reading that requires immediate intervention from a doctor. Or in manufacturing, identifying unexpected machine behavior right before a total system failure occurs.
Which brings us to our final stop, Section 5, the ultimate BI showdown. We've met the beat cop and we've met the forensic investigator, so let's put them side by side. On the left, we have OLAP. It explores and summarizes. It uses interactive reporting and drill downs, and it asks, what happened and where? On the right, data mining. It discovers those hidden patterns, uses model-based analysis, and asks, why is this happening and what happens next? So the crucial takeaway here is that they aren't competing. They are perfectly complementary forces. OLAP allows you to rapidly explore the past, while data mining allows you to deeply model and predict the future.
I want to leave you with this final thought and challenge. Imagine for a second that you are in charge of a supermarket's massive data warehouse filled with millions of sales and loyalty card records. Knowing what we've covered today, how would you use both OLAP and data mining techniques, things like clustering, regression, or anomaly detection, to help your managers actually improve the business? Think about the kinds of insights you could extract. It's a fun puzzle to solve. Thanks for joining me on this investigative journey today, and I'll see you on the next explainer.